Hi class, this lesson is over section 2.8, Proving Angle Relationships. The learning objective for this lesson will be to write proofs involving supplementary, complementary, right, and congruent angles. First, you will need to locate your properties chart on the back of your notes. You will be using this for reasons during the proofs. Remember that we went over these different properties in class and what they mean. You will also need to remember your angle relationships. Remember that vertical angles are opposite angles formed by two intersecting lines. So on this first one, angles 1 and 2 are vertical angles, and angles 3 and 4 are vertical angles. Also remember that vertical angles are congruent. Adjacent angles are angles that are next to each other. They have to share a common side. Complementary angles add up to 90 degrees, and supplementary angles add up to 180 degrees. Linear pairs are also supplementary angles. A linear pair means that it forms a line. We also need to go over some right angle theorems. First, perpendicular lines intersect to form 4 right angles. So if line AC and line DB are perpendicular, that means that angles 1, 2, 3, and 4 are all right angles. Notice that this symbol right here means perpendicular. Next one, all right angles are congruent. Since they all have the same measure, you can say that they're all congruent. So if all 4 of these angles are right angles, then all 4 of them are congruent. Perpendicular lines form congruent adjacent angles. So if you have the two perpendicular lines AC and DB, angles 1 and 2 are adjacent, and they are also going to be congruent because they're both going to be 90 degrees. Two angles are congruent and supplementary, then each angle is a right angle. So let's think about that. If it's congruent and supplementary, it has to add up to 180, and they both have to be the same. So that would mean that both of them would have to be 90 degrees, which are right angles. If two congruent angles form a linear pair, then they are right angles. So here we have angles 7 and 8 forming a linear pair, and I'm going to tell you that these two angles right here are congruent, which means that they would both have to be 90 degrees. Let's also review the angle addition postulate. If D is on the interior of angle ABC, then angle ABD and DBC are going to equal up to angle ABC. You can add them together to get the bigger angle. So let's try an example of angle addition. Find the measure of angle 1 if the measure of angle 2 is 56 and the measure of angle JKL is 145. Well, to complete this, you would just need to subtract 56 from 145, which would give you your answer. So to set this up geometrically, we know the measure of angle 1 plus the measure of angle 2 equals the measure of JKL. If we plug in what we know, we then see that we need to subtract over this 56 degrees to get our answer. So your answer would be 89 degrees. So let's try doing a proof that involves angle addition. We are given that the measure of ABC is 90 degrees. That's already notated for you. And we want to solve for x. So we just need to fill in these missing reasons. Your first statement is always going to be the given statement, which ours was that the measure of ABC is 90 degrees. The next statement and reason is showing the angle addition postulate, that this angle plus this angle is going to equal angle ABC. We are adding the angles together because we're trying to find what x is. On the next step, we have what angle ABD is equal to, we have what angle DBC is equal to, and we have what angle ABC is equal to. So the reason for this is that we use substitution to plug in which each angle is equal to. So our reason is substitution. Now we combined like terms to get 2x plus 4 is equal to 90. Then we subtracted 4 from each side to get 2x is equal to 86. And finally, we divided by 2 to get x is equal to 43. These theorems are going to be listed on the back of your properties charts. I actually wrote them in for you. We did go over these in chapter 1, but I want to go over them again. The congruent supplements theorem says that angles supplementary to the same angle are congruent. So if you have two angles that are supplementary to the same angle, then those two angles are congruent. Here's an example. If the measure of angle 1 plus the measure of angle 2 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180, see how you added 1 to 2 and 3 to 2 to get 180 each time? Well, that means that angle 1 is going to be congruent to angle 3, because you're adding to the same angle each time to get 180. The same thing works for complements. The congruent complements theorem says that angles complementary to the same angle or two congruent angles are going to be congruent. So if two angles are complementary to the same angle, then those two angles are congruent. Here's an example. If the measure of angle 4 plus the measure of angle 5 is equal to 90, and the measure of angle 5 plus the measure of angle 6 is equal to 90, since 4 is added to 5 and 6 is added to 5 to get 90 each time, we can say that 4 and 6 are congruent. The last theorem we're going to review is if two angles are vertical angles, then they are congruent. And a way to abbreviate that is vertical angles are congruent. Let's try our first real angle relationship proof. We are given that the measure of angle 1 is equal to the measure of angle 3. So I am immediately going to mark that on my picture, that these two angles are congruent. We're proving that the measure of ABE is equal to the measure of DBC. So first, let's plug in our given statement. Next, we need to figure out the reason for our next statement. Well, I see that I'm adding two angles together to get a bigger angle, and I'm adding two angles together to get the bigger angle. So I know my reason for this is going to be angle addition postulate. Let's see what changes from step 2 to step 3. Well, I'm looking at the measure of ABE for both of these because that's what they both have in common. Up here it has the measure of angle 1 plus the measure of angle 2 is equal to the measure of ABE. And down here it has the measure of angle 3 plus the measure of angle 2 is equal to the measure of ABE. So, what could be the reason of why we switched the measure of angle 1 to the measure of angle 3? Well, up here on the first step it said that they were equal, so you can use substitution to plug in the measure of angle 3 for the measure of angle 1. Then our last step that we need to fill in says that we're going to use substitution again. So we know this is going to be our proof statement. Your proof statement is always your last statement, but let's talk about why this proof statement is true. How do I know the measure of ABE is equal to the measure of DBC? Well, here we have the measure of ABE, and here we have the measure of DBC. Do you guys see how we're adding the same two angles for both of those? The right-hand side of both of these equations is the same, so that means we can set the left-hand sides equal. Since you're adding the same two angles on both of these, that means that these two angles have to be congruent. Our last proof. Prove that if ray DB bisects angle ADC, then angle 2 is congruent to angle 3. So first I'm going to fill in what my given statement is, because right now this isn't in the form of given and prove. So let's go ahead and do that. So it says that if DB bisects angle ADC. So this part right here is going to be my given statement, that DB bisects angle ADC. I'm actually going to come over here and show that on my picture. If something is bisecting an angle, it means that it's going to create two congruent angles. So if DB is bisecting ADC, I know that angle 1 and angle 2 are going to be congruent. Next, I'm proving that angle 2 is congruent to angle 3. So let's start filling in our statements and reasons. Our first statement is always going to be our proof statement, that ray DB bisects angle ADC. My next statement is showing that angle 1 is congruent to angle 2. How do I know that angle 1 is congruent to angle 2? Well, we talked about that. It's because it's bisecting. So the reason for this is going to be the definition of bisect. You can always use definitions as reasons. Next, angle 1 and angle 3 are vertical angles. How do I know angle 1 and angle 3 are vertical angles? Well, I know that because I know the definition of vertical angles. Step 4, angle 3 is congruent to angle 1. How do I know that these two angles are congruent? I know they're congruent because they're vertical angles, and we talked about this theorem earlier, so you're just going to put vertical angles are congruent. Next we have angle 3 is congruent to angle 2. Well, nowhere in my picture is it showing that right now, so let's look back in my proof. How do I go from 3 being congruent to 1 to 3 being congruent to 2? How did 1 change to 2? Well, up here it tells me angle 1 is congruent to angle 2, so that means I can use substitution to say that angle 1 equals angle 2. I plugged in angle 2 for angle 1. Now I'm just flipping the angle 3 and the angle 2 across the congruent sign. Look on your properties chart and you'll see that this is using the symmetric property. So I've proved my proof statement. That's all for this lesson. Please fill out your WSQ and ask any questions that you have.